Good afternoon, everyone. My name is Terry McManus, the President and CEO of RTCA. Greetings from our nation's capital and welcome to all of you to what is now our 19th in a series of webinars, Aviation Technology Connect. We are pleased to have created this series via this platform to hear from a variety of aviation industry leaders on a broad spectrum of topics which will educate you, further inspire you in your profession, and perhaps even evolve your thinking as to where the industry is today and where it's going in the future. Now, over the past year and a half, our webinar series has been highly successful, exceeding all of our expectations here at RTCA. We have attracted an international audience each month from both here in the United States, but also from Canada, countries across Europe, the Middle East, Africa, South America, Australia, and New Zealand. And we believe that today's webinar will be equally exciting and informative. These previous webinars were recorded, as is this one. So if you want to go back and listen to any of our previous webinars, you can find those recordings on the RTCA YouTube channel. Now, we've been holding these webinars on the third Wednesday of each month. And like today, each of these webinars focus on a particular topic where you will gain insights from aviation leaders that I'm confident will be inspirational, strategic, or thought-provoking, with the primary goal of them giving you, the audience, the gift of their knowledge. Now, I know many of you watching today are familiar with RTCA, but we have some first-time visitors with us. So I want to take just a couple of minutes to familiarize you with who we are. RTCA is an aviation-centered standards development organization whose mission is to inspire the creation and the implementation of integrated performance standards that meet the changing global aviation environment, and to further ensure the safety, security, and the overall health of the aviation ecosystem. Now, in addition to developing standards, we also provide training to government and industry personnel on the application of those standards and developing the basis of certification and testing. Now, on the screen, you can see some of our upcoming training events. This month, we're kicking off our newest course, The Role of Human Factors in Flight Deck Design and Certification. After 2 years of development and in collaboration with government and industry recognized human factors experts, we're excited about this latest addition to the RTCA catalog of training classes. Also this month is our very popular course on DO 178C, Software Considerations in Airborne Systems and Equipment Certification. You can sign up for any of those courses via our website at www.rtca.org. If you're interested or have any questions about our training, our standards development work, or interested in becoming a part of the RTCA family of members so that you too can have a voice in developing standards, you can contact us directly through our website or via telephone. Our ability to bring you these webinars would not be possible without the generous sponsorships from our industry partners. Today, I'm especially thankful to the Airline Pilots Association, Collins Aerospace, and to the National Air Traffic Controllers Association, our gold corporate sponsors this year. And also sponsoring today's webinar is Garmin. On this platform, you're going to be able to submit questions to our panelists today. So to do so, just click on the Q&A tab, and we'll do our best to get all of your questions answered. And in addition, the slides being used in today's webinars will be available afterwards. So if you'd like a copy of them, please email us at membership@rtca.org. And then at the completion of today's panel, I'm going to be presenting this year's annual William E. Jackson Award. So you'll want to stick around for a few minutes at the end for this special presentation. So let's get started. Global Navigation Satellite Systems, or GNSS, is a very broad terminology for any satellite constellation that provides positioning, navigation, and timing services on a global or regional basis. Global Positioning Systems, or GPS, is the most commonly used GNSS system, but other countries around the world have been implementing, or at least attempting to implement, their own GNSS systems. This month, our webinar is going to focus on how Global Positioning Systems has transformed GNSS and why we need new standards for this evolving technology. So to kick things off, I'm pleased to introduce our moderator for today's topic, Mr. Chris Hegarty. Chris is the technical fellow for the MITRE Corporation, where he has worked primarily on aviation communications, navigation, and surveillance systems since 1992. No stranger to RTCA, Chris chairs our program management committee and is co-chair of RTCA Special Committee 159 on GNSS. So Chris, over to you.
Okay, thank you, Terry, and welcome everyone who's joined us for today's webinar. The title of the webinar, as Terry mentioned, is From GPS to GNSS. And next chart, please. I'll provide just a short bit of background before we get into the panel discussion. And as Terry mentioned, we would love to hear also from you with questions you may have on the topic. The theme of today's webinar is From GPS to GNSS. And as Terry mentioned, Global Positioning System was the first satellite navigation system in widespread use, and it's evolving now to include a number of other constellations. RTCA has a very long history of developing standards in this area. Their Special Committee 159 on GPS was established 37 years ago now. Back in that time frame, there were only 7 operational satellites, and this committee was formed shortly after the tragic incident where a Korean airline aircraft carrying many passengers was shot down, and President Reagan within the United States declared GPS freely available for civilian use. It wasn't until 1995 that GPS even became fully operational. Among many products over the past several decades, SC-159 has produced a very widely used and mature suite of single frequency augmented GPS standards. And where a lot of energy has been spent since then is on the current suite of products on dual frequency multi-constellation standards for GNSS. And as with most RTCA efforts today, we prefer to do business with our colleagues over in Europe with EUROCAE. In particular, for GNSS standards, this is work ongoing with EUROCAE's Working Group 62 for Galileo. Next, please. Terry gave a definition of GNSS. There is a formal one actually used that's slightly different by the International Civil Aviation Organization. And they define GNSS actually to be the global collection of satellite navigation constellations plus equipment on aircraft augmented as necessary to meet the very rigorous standards and requirements that we have for safety of flight. ICAO originally developed standards for GNSS that only encompass 2 constellations, the US Global Positioning System and Russia's GLONASS system. Over the 2 decades now since ICAO adopted standards for GNSS, a lot of work has gone on adding additional constellations that are being deployed in Europe. Their Galileo system, which now has 22 satellites on orbit and has set healthy. And the Chinese Beidou system, which actually is the largest single global satellite navigation system today with 44 operational satellites to date. ICAO also formally defines 3 augmentations in order to take these core constellation performance up to what's needed to safely navigate aircraft. These include ABAS for aircraft-based augmentation systems, things like looking at consistency checks amongst signals for GNSS receivers. GBAS, which uses GPS or GNSS receivers at airports and a VHF data link to send corrections and integrity data to aircraft in the vicinity of the airport. And satellite-based augmentation systems, or SBASs, systems like WAAS in North America or Gnss in Europe that actually use a continent-sized network of GNSS receivers on the ground to do something similar to GBAS, but using a satellite link to provide coverage over a very large area. Next, please. As mentioned earlier, RTCA's standards for GPS have been very widely used, and these standards focused on only civil GPS signals on one frequency, which is all that existed back when RTCA began their business and when ICAO began standardizing GNSS. At the time, the GPS satellites only had one civil signal, and that was what was embraced and is what is most widely used nowadays to navigate aircraft. RTCA has developed standards for GPS receivers on aircraft, for the antennas, and for GPS equipment augmented by SBAS, GBAS, and ABAS as listed in the table here. Very importantly, the US isn't the only one using GPS for aircraft. Europe and many other safety regulators around the world have also embraced the use of GPS on aircraft and furthermore have invoked RTCA standards, as does the FAA. EASA is a very good example for what's going on in Europe. Next, please. If you fly an aircraft or travel as a passenger on an aircraft, you've probably come close to equipment that's been built to SC-159 standards. These are just some examples, with many thanks to the vendors who've provided these graphics for use in today's webinar. Next, please. What we're busy with nowadays within RTCA and EUROCAE is working on next generation standards. These are standards that are being built to embrace the additional satellites that are being afforded by the billion-dollar investments made by countries and groups of countries around the world, as well as the modernization of GPS and other core constellations that were already in ICAO SARPs. What's happening for GPS in particular is that they are adding 3 additional civil signals, one of which was dedicated specifically for aviation use, known as GPS L5. So we've already produced some products to support the next generation avionics standards, including a couple of interference reports, one done and one nearly done to support interference requirements for the next generation avionics. And some of the big products that are coming up include the receiver standards for GNSS augmented by SBAS, as well as later on for ones augmented by GBAS, and some other products that are listed in the table here. Next, please. It hasn't been easy. We still have quite a bit of work to do, and the work has been proceeding slower than some might like. The panel will actually focus attention to some of the challenges that are involved with the work that's ongoing now in RTCA and EUROCAE. And these are just some of the challenges I think we may hear about from the experts that we'll introduce shortly. First of all, unlike many other aviation systems that are put in place by aviation authorities or air navigation service providers, in this case here, we're relying on systems that are built to support many, many users well beyond aviation. For instance, the GPS program in the United States in this fiscal year alone has allocated or appropriated over $2 billion. And the programs for the other core constellations being deployed around the world represent similar investments. Anyone who's dealt with space systems realizes that these schedules often slip. In 2001, the US official planning document for federal radio navigation systems predicted that we would have 24 GPS satellites that had the third civilian GPS signal that's going to be used by aviation, L5, on it. As of today, in 2022, 8 years later than this, we still are at only 17 satellites, with 7 to go to complete even a nominal constellation size of 24. There are challenges with ensuring safety with multi-constellation avionics. What many of you may know of as RAIM, for consistency checks that are performed in many GNSS receivers, is evolving into advanced RAIM or ARAIM. And there's also work underway to actually modernize and update some of the ground networks that are used to provide integrity in SBAS and GBAS systems. There have been a lot of discussions within RTCA and EUROCAE and making sure that we had features to ensure that we have a positive benefit cost ratio for equipment to be built to the new standards. A lot of discussion of concerns or issues and complexities involving equipment modes. The need for future equipment to be compatible with a growing number of adjacent band radio systems. And also for the need for us to deal with some emerging threats to GNSS, including jamming and spoofing. Next, please. So to join us today in this panel discussion of some of these challenges and anything else related to this topic of the development of these new standards, we're very fortunate to have a very experienced set of individuals with deep experience in GNSS, and also that are each and every one of them are part of the leadership team of Special Committee 159. The panelists include Laurent Azoulai from Airbus. He's a senior expert for navigation systems there. Ms. Barbara Clark, who is an aerospace engineer with the FAA. She is the government authorized representative for SC-159 from the FAA within their Office for Certification, Policy, and Innovation. Dr. George Ligler, who's a professor with Texas A&M and has a long history with SC-159. And we don't have time to go through all of their backgrounds and deep experience, but I'd welcome you to go to the RTCA website for this webinar where you can find their complete bios. So thank you all for joining us today. I'd like to, to just kick off the panel here, I'd like to ask each one of the panelists to share their thoughts on some of the challenges we mentioned or any other challenges that they see as being drivers in the work that the aviation community has underway on GNSS. And before I begin that, I'd also, again, like to encourage everyone participating in the audience to ask questions if you have any to the Q&A window in Zoom here. And as soon as we get a little bit underway in our discussion, we'll turn to that panel there to hopefully ask some questions that you may have. So let's begin with you, Laurent. What are your thoughts, I guess, on some of the challenges we're facing?
Well, thank you very much, Chris, for this question. Well, you know, in the industry, we always have a coordinated approach to simplify the integration and use of GNSS in cockpits in navigation. The thing is that some states have expressed the willingness to mandate the use and/or the installation and/or use of their core constellation or prohibit the use of other constellations. But in the past, air navigation conferences have always said that they would not recommend such approach, and Airbus support this recommendation. What we want to avoid in the new MOPS, and we are working on this, is to avoid that the complexity induced by the new modes, the multiplicity of modes induced by these potential mandates, will convert into complexity for the flight crews, for the human-machine interface, and for the airline operations.
Okay, thank you, Laurent. I'm sure we'll talk more about that challenge as we go. Barbara, any opening remarks on challenges that you'd like to make, please?
Yeah, I don't think we're at a loss for challenges for new MOPS. I'd like to just note a couple of them. The first one is a bit broader than the immediate MOPS that you had on your on our summary screen for the work program for SC-159, and it's also a little retrospective. I've noticed and observed that since we started the standardization of satellite navigation for aviation with both GPS and GLONASS, we have built in a framework, if you will, for having multi-constellation. But we've exploded in the number of constellations that we have and the number of ranging sources that we have, and it's kind of a new world, yet it's easier for us to just plug and play core constellations without going back and reflecting on our decades of experience now with GPS and GLONASS and rethinking and trying to reimagine what we can do. For the MOPS that we have in our work program right now, many of the decisions, as we'll talk about, are made, you know, for the dual frequency multi-constellation SBAS. And our GBAS colleagues are trying to do a little bit of reimagining to update from our carrier smooth code and whatnot. But going forward with this abundance of satellite navigation assets, I think we need to try and unleash our engineers a little bit more, which is difficult when we have constraints from our prior framework, like bandwidth, you know, literal constraints on our VDB and on our SBAS channels. So that's one thing. The other thing on your slide of challenges, the last one you mentioned was jamming and spoofing. I remember the difficulties that we had with thou shalt not output misleading information in the presence of interference, which is a requirement that we've had on the books for a long time. With the added complexities that we have and the new requirements that we want to add for robustness to address the interference events that we see, both planned and unplanned, I personally am concerned about the development of our test scenarios and making sure that we have a good, practical, but also executable way to verify the compliance of our new equipment. Those are things I'd think about.
Yeah, thank you, Barbara. And in the meanwhile, we're seeing one other challenge we've been facing in these in the post-COVID days with international meetings through video conferences. We've briefly lost Laurent, but hopefully he'll rejoin us shortly. And George, do you have any opening thoughts on some of these challenges, please?
Well, thank you, Chris. And good afternoon or evening, as the case may be, everyone. One thing that we need to keep in mind, and it touches a bit on what Laurent told us, is that we need to make sure we have an appropriate cost-benefit ratio for the use of this equipment. It's wonderful to have the technical capabilities, and we're all excited about having additional ranging sources and greater accuracy, reduction of ionospheric distortion through the use of 2 frequencies, greater resiliency, all great stuff. What are the practical benefits for the users? And there are several, but I think we'll be defining more over time. Greater resilience, because we have multiple frequencies and additional ranging sources, certainly. Greater accuracy at the point of the receiver because of the dual frequency, which may well provide a receiver that'll be a better position source for things like automatic dependent surveillance broadcast, as well as for new navigation operations or newly enabled navigation operations. So we need to keep an eye on what that cost benefit is. Outside of areas of SBAS coverage, I think the benefits will increase substantially for people who choose to equip. Laurent also brought up the reversionary modes, geopolitical mandates, things of this nature. In developing our MOPS, we need to do the best we can in this situation to ensure that we have fairly seamless operation from the aircrew perspective. It would be excellent to avoid constellation selections being done by the aircrew. I mean, this is certainly a situation that we're concerned about and want to avoid if we at all can. With regard to reversionary modes, no system, even with 2 frequencies and many ranging sources, is 100% available. GNSS is highly available, but in those areas or at those times that we don't have a particular availability, we do need to have reversionary modes of navigation and supplying position to surveillance sources and a graceful degradation. And this is something that the air navigation service providers around the world have been planning for a number of years. From an equipment perspective, we simply need to make sure that our equipment, our GNSS equipment, integrates into the aircraft in an appropriate manner to support graceful degradation.
Great, thank you, George. And Laurent, welcome back. Hopefully you can hear me. Laurent, can you describe for some of our audience members what typical equipage is for GNSS on the fleet of Airbus aircraft and how that equipment's used?
Yes, sorry about that. I hope you hear me well. Okay, I'm back. Yes, well, on our aircraft, A220, A320, A330, A350, and A380 now, the whole fleet, also on A300, the legacy aircraft. We all have GPS embedded on the aircraft, also SBAS and GBAS. What we are doing is that you are blending GPS and INS, as you mentioned earlier, the ABAS function, but we also proposed SBAS landing system function that we have recently certified and delivered as a first embodiment on EasyJet on A320. And also it was available from entry into service to A220 and A350. And we support RNP with LPV category 1 minima approaches. We also have the GBAS landing system supporting automatic landing under category 1 minima. And what we do with the ABAS function is that we support from en route to non-precision approach RNP operation with high availability and high continuity all around the world.
Thank you, Laurent. Just looking at the audience has weighed in actually on something related to some of the comments that you made, George. So I'd like to see if you want to respond to that one now. Bruce Johnson asks, whose cost and whose benefit? Don't we need this to be done at an industry basis with all stakeholders? How do we accomplish that?
Very good question. Clearly, the people paying for the equipment need to get a reasonable cost benefit for their operations. That can be supplied in a number of ways. So I would say in terms of people who buy the equipment need to see that there's a reasonable cost benefit. The alternative to that is to have air navigation service providers mandate equipage. And this is something which has a very long timeline, is somewhat difficult to do. And we've done it in the past, but as an industry, but avoiding the mandate route through providing cost benefits and voluntary equipage, I think is the preferred route for pretty much everyone.
Yeah, George, I think the fear when people hear the word mandate, especially when they put it in with cost benefit, is why, meaning the additional services in ionoactive regions, you can say, I see that benefit, but for some of the operations, we are providing additional means to achieve the same operation. And I think that's where a lot of the fear comes in with the mandate. You know, I can already do this, so why do I need a second or third way to do it? Especially when you want to have robustness against the loss of satellite navigation altogether, and you want to combine your conventional nav aid or other means.
Right. An example of what Barbara just told us is with regard to position sources for ADS-B. A number of our air transport operators within the United States are currently operating with existing legacy GPS avionics as their ADS-B position sources under an exemption that was granted by the Federal Aviation Administration for particular circumstances. They would be and have articulated a desire in some quarters to use dual frequency multi-constellation receivers to avoid being in an effective mandate to use a single frequency SBAS receiver, for example. So there are ways that, and the example that I've just given shows that there is a way through these problems. There is a way for the industry and the air navigation service providers to work together, as has been done with the ADS-B position source in the United States, to get that cost benefit maximized and to cooperatively improve the airspace.
A follow-on to some of the points you just made, Laurent, about equipage on Airbus. For Airbus, can you clarify if SBAS and GBAS are part of the basic configuration, or are these add-ons?
Well, SBAS and GBAS are selectable options for our customers, but I think they can get great benefits. And well, we expect that with the dual-frequency multi-constellation, one of the benefits will be to extend the number of operations by extending the footprint of SBAS to perform the LPV operations. But I would like to rebound on what was just said about the fear and the benefits. Actually, that's one thing. Well, it's going to extend this number of airports accessible with SBAS, but on the other hand, it's difficult to see that does it balance sufficiently the cost induced by the introduction of Dfmc SBAS? And one other aspect that often is, let's say, communicated to us by states is the notion of sovereignty. And so we need to understand, what does it mean, sovereignty? Why do we need to have these mandates? For what reason exactly? And when we understand the rationale behind it, we can analyze this rationale and maybe make some suggestion on how we can integrate it on the aircraft and serve our customer while limiting the cost of introduction of Dfmc SBAS.
Some great questions are coming in here, so sorry to be jumping topics, but I want to catch as many of them as we can. I guess maybe a quick one. Please define Ionoactive regions. I don't recall who brought those words up, but Iono, of course, stands for the ionosphere, and I don't know if anyone wants to take.
I think I use that phrase, Chris, and I was referring to primarily equatorial, geomagnetic equatorial regions where you have more active Iono.
Thank you, Barbara. Yes, we do expect the worst case ionospheric errors and the greatest prevalence of scintillation and other things within about 20 degrees plus or minus of the Earth's geomagnetic equator. An anonymous attendee has asked if Dfmc MOPS will provide a path for increased integrity to support SVO and eventually autonomy that are advanced by the advanced air mobility market. I can give a quick thought on that and then open it, but in case the audience isn't aware of it, there is a special committee that RTCA runs that works also jointly with EUROCAE of SC 228 on unmanned aircraft systems. That has a working group now on navigation for systems specifically for unmanned aircraft systems. And they've been looking at gaps in existing standards on navigation to see if there is a need for additional ones in order to support emerging unmanned operations such as AAM markets. So I haven't read the draft document to put together yet, but hopefully that they would address that gap, or if they haven't, if you want to weigh in on their final review and comment of that document, that might be an excellent comment to feed in. I don't know if anyone has other thoughts on that one question.
I've got a few on the advanced aerial mobility. There are several modes of AAM, and as has been mentioned, and as the questioner clearly knows, it's a very hot topic. Some of them involve piloting aircraft with hybrid or all-electric drives and various applications up to and including a sort of an air taxi service within urban areas. I think the dual-frequency multi-constellation MOPS will help those types of operations perform better. Additional ranging sources in urban areas, I think, will end up being of significant benefit. With regard to the autonomous side of advanced aerial mobility, Chris, I think your comments are spot on.
Thank you, George. And another easy one that I'll try and knock off here is just a question on the timing of the Dfmc standards. That was in one of the charts, and just to make sure I don't misspeak in my answer on that one, we are planning to do two different minimum operational performance standards with two different drops for each one. So the first one will actually be one that does SBAS as the augmentation, and then a later set on GBAS. But the SBAS MOPS timing now calls for us to have an initial draft done by March of next calendar year, 2023, and then an updated version in October 24. The GBAS Dfmc MOPS is a bit later, December 24 for the first drop and December 28 for the next. And anyone who's been following us for a while knows that we have seen some slippage due to some of the things beyond our control, as mentioned in one of the opening slides there. There's a lot of questions on threats coming in. asking, I guess, Ernest, for example, asked what's being done to detect and properly respond to intentional spoofing on the cybersecurity front. I don't know if anyone would like to take first crack at that one.
Yeah, I can take that one. I mean, initiate the topic. So, well, we are seeing an increase in what we call radio frequency interference event in the field, affecting our customers, especially close to theater or military theater of operations. So, well, indeed, if you have such event, it will degrade the position capability using GPS, but our aircraft are equipped with all the systems needed to navigate with and to provide surveillance without the use of GPS, thanks to the inertia system, the Gnss, and also thanks to the ground network of radio navigation heads. And so we have a lot of operations procedure that support our customer or flight crews in case this happens, and we provide this recommendation to the crew. And we are currently monitoring the situation with multiple partners such as ICAO, IATA, also.
Looks like we may have lost Laurent again. I guess we'll turn it to some of the other panelists. I guess just a quick interjection while I have the mic here, but I should point out that the terms of reference for SC 159 does actually call for us to address, to the extent practicable, the emerging threats of jamming and spoofing. So there is a lot of energy into making sure the next generation of equipment at least has some capability to detect the presence of false GNSS signals, which we call spoofing. And it's actually one of Laurent's colleagues at Airbus who's taken the lead at developing some draft material in that regard. There's a lot of work that needs to be done to make sure that we have a set of requirements that we can test and also avoid getting into intellectual property issues and those sorts of things. But there is a hope and a strong drive right now amongst the manufacturers to tackle this through some new capabilities in the equipment, in addition to some of the things that Laurent mentioned that are existing capabilities on aircraft that may help in the event of a spoofing attack. Laurent, I was tap dancing a little bit while we lost you again. I don't know if you wanted to pick up with your thoughts at that point. Yeah, no problem.
Yeah, so I was saying that we have procedures supporting our operators, and we are working with all the international organizations, ICAO, IATA, also the Pilots Association, the manufacturer, the regulator, airworthiness authorities, monitoring the situation, see if we need to improve the receiver and the avionics in case this becomes something that cannot be bearable. At this stage, in the Dfmc SBAS MOP standards, we are looking at improving the receiver, taking this opportunity by providing detection and reporting capability, and also improving the resilience against these sources of interference. So something we are monitoring, and we are looking at making the new standards, integrating potential improvement, adapting to the situation.
Yeah, thank you, Laurent. Did anyone want to add to that?
Yeah, I think we should also, note that Mr. Condon was right by saying or focusing on the detection, because playing through all intentional spoofing is not something that is realistic for civil aviation. So the detection is the key, as both the commenter and Laurent noted. We've also at RTCA just published a new MOPS for GPS inertial, highlighting the fact that the integrations can help once detection is there. And then the last thing I'd like to note is that ICAO is actively pursuing or looking at whether or not SBAS should provide message authentication, so from a service provision standpoint. So that would give us another layer of protection.
And on that topic, Barbara, I did want to ask you at one point, and I might as well jump it to now, about the relationship between RTCA and EUROCAE and ICAO and the status of ICAO's work program, if you wouldn't mind educating us on that, please.
Okay. Well, I like to think of ICAO standards and recommended practices, which we affectionately call SARPs, as the parent set of requirements or the parent document for our MOPS. So currently, we have in the ICAO standards just GPS and GLONASS, as you mentioned at the outset, but we've now added into that the new constellations. When we did that, we were able to take the performance standards and the interface control documents from each of the core constellation providers and extract from them the signals and services that would be intended for aviation use, and try to provide the level of detail in the SARPs that would support the development of the augmentation systems. So that whole ICAO effort lends itself to promoting compatibility, interoperability, and transparency. As you mentioned at the outset, these constellations weren't built just for us. So not surprisingly, there are differences in the way the different service providers provide or standardize their systems, literally how the requirements are written, how the monitoring, how the integrity requirements are written. So ICAO's efforts to standardize and validate those amendments to Annex 10 provided a foundation for us to do our work. A few years ago, representatives from the United States, Russian Federation, European Union, People's Republic of China, and Japan sat down and went through all of these documents and did a validation effort. That was completed, don't hold me to the date, circa late 2020 or so. ICAO has now gone through the process to the point where the Air Navigation Commission had put a state letter out, which is basically saying, hey, we want to adopt these standards, and we currently envision them to be applicable in 2023. So we have we've added material to reflect that the GPS standard positioning service is being modernized. We've added the pair of signals, I5 and Q5 code on the L5 frequency. So we reflect that now in the standards. We've added to the GLONASS standards the CDMA signals in L1 and L3 bands. We've added the Galileo open service dual frequency into Annex 10 and also BDS open service. Actually, for BDS, you end up with B1C and B2A for their dual frequency, and a third option for B1I for single frequency operations. So all of that is it has been incorporated, and as I said, it's 2023 for applicability. Is that kind of what you were looking for?
Yeah, that's great. And in
Okay.
fact, I'm trying to remember, I guess Amendment 76, if I recall, to Annex 10 of the International Agreement on Civil Aviation was the first time that we had GNSS added with GPS and GLONASS. But what are we up to now with the?
Like 92.
Okay.
But all of those weren't us. You know,
Right,
there are other amendments to
the whole appendix. It includes aeronautical, telecom, and other things. So, thank you. Thanks very much. Unless anyone had anything to add on ICAO. If not, I think we had mostly answered Ernest's question on spoofing, but I did want to mention just one other tie-in to some other work that RTCA has going on. When you use the term cybersecurity, there's concern, of course, of spoofing of GNSS signals over the air with someone creating false GNSS signals that are broadcast wirelessly. There's also the worry about tampering, getting into aircraft networks to insert a bad position and other things on the aircraft side. So there's another RTCA EUROCAE effort in that regard that has produced a bunch of documents on cybersecurity for specifically for networks on the aircraft to make sure that that is protected as well. So I wanted to keep your question alive just to point that out. And that's being used today for larger aircraft, and for smaller aircraft, a partner, SDO, Standards Development Organization of ASTM, has recently completed some standards that are going to be used for small general aviation type aircraft that you might be interested in. We had a question on GPS spectrum issues regarding, in particular, the FCC's recent approval, or back to March 2020, I guess, approval of 5G services and bands adjacent to GPS. Did you want to take a crack, George, at a response there about how that will impact current and future GNS receivers, I guess, for our conversation, restricted to of interest for the aviation community, please?
Sure. In fact, taking on to the last discussion before you asked the question, I think it's important for our listeners to understand how much work Special Committee 159 and EUROCAE have been doing on interference to the GNSS. Those updated standards or updated interference environment descriptions for L1 recently completed, for L5 in progress, are huge tasks, because the interference environment, and the reason we needed to update the documents, is the frequencies are becoming much more used, both close to and on the GNSS frequencies themselves. It seems to be in vogue nowadays for as many people to offer geostationary overlays like WAAS as possible in particular parts of the world. We've had to add, by way of example, in some of our recent standards for SBAS augmented GPS, additional codes to identify additional geostationary satellites, because we ran out of codes and had to identify more because of the plans of various states. So we have on-frequency interference. I mean, the good news is we have more constellations and more ranging sources and more geostationary overlays. The bad news from an interference perspective is more and more folks are broadcasting signals on frequency. With regard to the near GPS, GNSS frequency stuff, it's very, very difficult dealing with, and SC-159 has been dealing with the issues with regard to folks near the GPS frequency putting significant ground station infrastructure in to implement more advanced telecommunication systems. It's a constant state of negotiation, understanding, eventually coming to consensus. I think we've been through, what, 2 or 3 rounds of that within the past decade, and I don't see that ending. So one key thing that we're doing in our new MOPS is making our, going forward, our Dfmc receivers much more resilient, necessarily so, to these interference sources, which is an important reason that we're completing the interference environment descriptions, because those are going to guide the interference rejection requirements on the receivers.
Great, thank you, George. And that's been a real challenge, because the interference environment changes almost faster than we can document what it is. Specifically, I guess on your question, the company that the FCC did recently provide authorization to is called Legato Networks, and they actually are participating in our committee and have helped us with our new interference standards. So I think we all want aviation and telecom to work nicely with one another. One residual issue, though, that we can't really impact at this point is our aircraft that were built to our existing single frequency standards that came out before the authorization was obtained. Some of the owners and operators of that equipment are still concerned with operations that may be closer to the base stations than what was assumed by the FCC in the FCC's decision to authorize them at a certain power level. So there are some residual concerns there. And if you're interested in that, I'd encourage you just to look at the public filings on the FCC's docket for that led to that order. Anyone else want to weigh in on that one? Laurent doesn't have to worry about this yet in Europe. We have, let's see, some more questions coming in. What's the greater risk, spoofing or jamming? And does the proposed SBAS authentication discriminate against jamming signals? Anyone want to take that, Barbara or Laurent, perhaps?
Well, I'll start first. Well, I don't know if the question is about the probability of the event or the effect of the event. So what we are currently seeing is that we have multiple cases of jamming around the world. But as I said earlier, aircraft and our aircraft specifically are equipped to support, to sustain this environment, and either to continue by using inertia system or also to revert back to ground navets. And I would like to point out an important point is that while people evolve towards GNSS in states from infrastructure, we need to make sure that we maintain a minimum operational network of ground radio navigation heads to support the resilience in case we lose GNSS. It can be just unintentional, and sometimes it's intentional because we are close to a border of a state that has some conflicts. So the jamming case is, let's say, the most probable. Spoofing case is, let's say, probably much more difficult to happen. It's considerably complex to put in place a spoofing. So far, we haven't seen spoofing events. We are looking at some suspicious cases, very few, maybe a couple, where it could be, let's say, a collateral effect of a spoofing that was aimed at, maybe protect an area or whatever government location. But we are looking at it, and as I said, in the Dfmc SBAS mode receiver and with SBAS authentication, monitoring the situation with airworthiness authorities, will take additional measures if needed in the standards for future receivers.
Thank you, Laurent. And Barbara, I don't know if you want to pick up on effect. So I think most people worry more about spoofing than jamming because of the effect on the aircraft. Perhaps you could provide some thoughts on that, Barbara, on what worst case happens, I guess, if you're jammed versus what happens worst case if you're spoofed.
I'd like to actually just keep that a little high level. Jamming by definition is denial of signal, and spoofing is misleading information that is undetected by the aircraft. So the effect of spoofing is limited only by your imagination if you're talking at the equipment level.
Yeah, I think that was exactly what I was looking
yes.
for. Just that we worry more about spoofing as an integrity threat, whereas
Right.
jamming is more of an availability or continuity threat, which still can impact safety, but it's part of the reason why most ANSPs are keeping a lot of traditional nav aids around in the event of outages like that.
Right.
Okay, thank you. As to the question, you had a specific question in the one we just addressed on whether authentication can help with jamming. Authentication is actually the concepts that are in mind now are adding cryptographic features, digital signatures, for instance, to the signals, just to make sure that you can trust that they came from an authorized service provider and not from someone trying to mess with you. So it doesn't help for jamming, really. The intent is just to help somewhat with certain spoofing attacks. Let's see here. Another question on Dfmc specifically for drone flight operations. I don't know if anyone wants to take a crack at that one from Pablo Haro.
I'll take a brief stab on it. Drone flights would benefit. It depends whether we're talking Dfmc with SBAS augmentation or without, but like any other user of GNSS, drones would get particular benefits out of reduction of ionospheric error in the position, and they would get additional resiliency out of the multiple frequencies. Perhaps the questioner could hum a few bars about what particular aspects of drone operations might provide discriminators to what I've just said.
And with an eye on the clock, looks like we have time for just a few more here. We're going to try and conclude this part of the webinar at the top of the hour. But we will just let people know if you please don't hesitate from asking questions, because we will actually try and answer the ones that we don't get to live here after the fact. So we certainly don't want to discourage you from asking them. Kerry asked a question that I'm not sure I follow, I guess, the issue, but how quickly can industry expect standards and equipment implementation that could specifically manage date and time shift events? I don't know if this is referring to things like leap seconds or the such. I don't know if any of the panelists have thoughts on an answer to that question. I think we need a little more clarity on that one, please, Kerry. There is a question asked here about EUROCAE, which maybe will lead us maybe into the last question of the day. We talked a little bit about interference events and talked also about how ANSPs are keeping other nav aids around to back up GPS outages as GPS or GNSS equipment becomes more and more capable. Any thoughts you all want to share on the need for complementary or alternative PNT systems?
And may give you some thoughts, Chris. Thanks for the question, because well, this is a valid question that we need to ensure that we have radio navigation aids as a backup to GNSS in case we lose it. The thing is that we already have probably everything that we need on the ground and on board, and we just need to make sure it's populated enough. It's the density of the network is sufficient to maintain the capability of the air traffic management. So currently, and we can do up to precision approach. We do RNP AR operation, RNP operation. So the best thing would be to be able to maintain as much as possible the same capability, so the air traffic control can manage the traffic. Having said that, what we want to avoid if anyone wants to deploy a new system is that there is an agreement at international level in ICAO that we have common system with common standard defined by ICAO that we can use worldwide. What we want to avoid is the proliferation of multiple systems with different definition that will end up with more equipment to carry on board aircraft, certify, and that will be cost and weight for the operators. And that's what we want to avoid. So I would suggest that we try to optimize what we have already and to make the best of it, and then see if we really need another system.
Great points. I see the other panelists nodding. Any thoughts you want to share on that, or anything else, Barbara, and then George, and then we'll be run out of time.
Pretty good.
Yeah, George.
I'd just like to point out that 159 had a GPS Laurent working group back in the 1990s, and Laurent and then EUROCAE are system topics that have come up intermittently in the 90s, and then we had another surge of activity perhaps 10 years ago, 10, 15 years ago. Very much concur with Laurent's views on this.
Looking at the clock, it is now the top of the hour and we are out of time. I'd like to sincerely thank the panel members for their participation today and help to keep this a nice, lively, and hopefully useful discussion for everyone. So thank you all. Thank you, Barbara, George, and Laurent. And thank you all very much in the audience for participating today. Some great questions were asked, and as we promised earlier, we will try our best to answer the ones we didn't get to after the webinar today. So thank you for joining us. And now let me turn the program back over to Terry for the presentation of the Jackson Award.
Thank you, Chris, for the great discussion, and to all of our panelists. Last month, I had the honor of presenting our annual RTCA William E. Jackson Award. We were able to record that presentation, so let's roll that tape right now. Each year, RTCA presents a scholarship award to an outstanding graduate student in the field of aviation electronics and telecommunications. This scholarship, which we first awarded in 1975, is named in honor of William E. Jackson, who was a true pioneer in the development and the implementation of this nation's air traffic control system, and he was an enthusiastic supporter of student engineers. His deep interest in engineering students was an inspiration for many in choosing a career in aviation. This year, I'm excited to present the 2022 William E. Jackson Award to Andrew Gnss from Ohio University for his master's thesis, Aircraft-Based GPS Augmentation Using an Onboard Radar Altimeter for Precision Approach and Landing of Unmanned Aircraft Systems. And by the way, he joins a long list of Jackson Award winners from the Avionics Research Center at Ohio University. Andrew graduated with a Master of Science degree in Electrical Engineering in March of 2020. And even as an undergraduate, he had shown a real keen interest in all aspects of aerial vehicle avionics. According to his thesis advisor at Ohio University, Andrew spent a lot of time in their research lab designing GPS and INS communication links for UAS operations, did flight test evaluations for UAS detect and avoid applications, and of course, what was reflected in his thesis leading to this award, the development of a navigation method that will enable approach and landing of uncrewed aerial systems. Since completing his master's degree, Andrew is now a technology and standards engineer at General Atomics Aeronautical Systems, working on the integration of unmanned aircraft systems into the National Airspace System. I'll add that Andrew is also involved with our special committee SC228 that is developing minimum performance standards of uncrewed aircraft systems. Again, congratulations on being selected as this year's award winner of the 2022 William E. Jackson Award. Andrew?
Thank you, Terry. It is an honor to receive this award. I've been lucky enough to interact with many of the previous Jackson Award winners, either as professors of mine, co-workers, or just colleagues passing by the conference. And it truly is an honor to be associated with them. I would just like to say a few thank yous. Firstly, I would like to thank my master's sponsor and current employer, General Atomics, and the employees at General Atomics who supported me throughout my graduate research. I'd also like to thank Ohio University and the Ohio University Avionics Engineering Center and all of the professors, students, and engineers I had the pleasure of working with while I was there. And finally, and most importantly, I would like to thank my mentor and research professor, Dr. Martin Outahag, for guiding me with his knowledge, experience, and expertise throughout my graduate research. Again, it's a true honor to receive this award, and thank you.
And Andrew, in addition to the nice award plaque that you'll be receiving, we've got this nice stipend in the amount of $5,000 that we'll be sending to you from RTCA, and all in recognition of your accomplishments. So again, congratulations, Andrew, and you've got a great career in front of you.
Thank you very much.
Again, thank you to our sponsors for today's webinar, the Airline Pilots Association, Collins Aerospace, and the National Air Traffic Controllers Association, our gold corporate sponsors this year, and to Garmin for sponsoring today's webinar. For the audience, thank you for joining us today. I hope you found today's presentations educational, inspiring, and evolving. And again, these webinars are being recorded, so if you want to review anything presented today or any of our past webinars, you can do so by going to the RTCA YouTube channel. I hope you'll all be able to join us for our next webinar, which will be held on Wednesday, July 20th, again at 1:00 p.m. Eastern Time, where we will have another fabulous discussion about a timely topic of interest to the aviation community. Thank you all again for being with us, and have a wonderful day.